dance if we want to. We can leave your friends behind, cause your friends don't dance, and if they don't dance, well, they're no friends of mine. I say we can...
In Chapter 6 for Chemistry 1, we're going to learn about the periodic table, how it's organized, why do we classify elements certain ways, and the periodic trends based on how they're organized. So first, we've known about some elements for thousands of years. Hopefully you're finding this out with your element project. Like copper, silver, and gold, they've been used for money, for riches, all that stuff for thousands of years. So early chemists used the properties of elements to sort them into groups. These properties that they looked at included chemical reactivity, metals, if it's a metal, if it's a non-metal, a gas, and all that kinds of stuff. The first guy who actually really delved into trying to organize it was Dobrinner. He was from Germany. In his system, the elements are classified in what are called triads, or a set of 3 elements with similar properties. Chlorine, bromine, and iodine formed triad, for example, because they have similar chemical properties. With these triads, the only problem was that not all of the known elements could be grouped together, because during that time, in the 1800s, he didn't know about all the elements. And so it was really hard. Dmitri Mendeleev is the next guy, and he actually published a table of elements in 1869. And he organized it by putting the elements with similar properties in the same row. And so pictured is a mock-up of what his periodic table looked like, his classification. Mendeleev developed his table while working on a textbook for his students. He was a teacher, and he needed a way for them to show the relationship between the 60 elements that he knew about. So he arranged them in order of increasing atomic mass. With his first periodic table, Mendeleev was even able to predict elements that hadn't been discovered yet. And notice the question marks on the picture. So on this grouping, he was able to, there's a question mark right there, question mark in the green box, but he was able to see, well, these have similar chemical properties and these don't, so I know I have to have a gap in there. And so it's very cool that he was able to do this because he predicted elements that we hadn't even thought of before or hadn't found yet. So other things in the red box are triads. Sodium, lithium, and potassium were all grouped as a triad by Dobrinner, and fluorine, chlorine, bromine, and iodine were all kind of grouped similarly because of their chemical properties. So he was using somewhat of what Dobrinner had thought of with grouping. So our periodic table today is arranged a little bit differently, and it has to do with the electron configuration. Remember the F block and how I said it's supposed to fit in before the D block? Well, down here is the F block, and so we have 6S, we hit 4F before we hit 5D. And so it's really hard to fit a lot of information in these tiny little boxes, so that's why we put the F block underneath the periodic table. Some differences between today's periodic table and Mendeleev's is that today's table is not solely arranged by atomic mass. So, like for example, iodine and beryllium are not arranged by their atomic mass. If we look on the periodic table, it goes antimony has an atomic number of 51 and the mass is 121.76. Beryllium has an atomic number of 52 and the mass is 127.60, and iodine has a atomic number of 53 and a mass of 126.90. So on Mendeleev's periodic table, these two guys were switched, but we have since switched them back because we arranged by increasing atomic number now, okay? And the atomic number corresponds with the number of electrons filling the atomic orbitals. Remember, if it has an atomic number of 44, that means it has 44 electrons. And so using our atomic orbitals, our S, P, D, and F, with electron configuration in Chapter 5 tells us this order now. Okay, so we have something that's called periodic law from the way that the table is arranged. And a period is each row in the periodic table, and they correspond to the principal energy level. Remember the quantum number n. Okay, that's why we have 7 energy levels, because we have 7 rows. Now we can say we have 7 periods. When arranged in order of increasing atomic number, there is repetition of elemental properties. The pattern of properties is repeated from one to the next. We call this periodic law. So as we go across the periodic table and then go down to the next row, the properties are repeated. And so this repetition gives us the periodic law. So we have 3 classes of elements. We have metals, nonmetals, and metalloids. Metals are very good conductors of heat and electric current. We have them to the left of the stair-step line, which we will cover in a little bit. That's why there's copper wiring in your house for wires to conduct electricity. If you are heating something up on the stove, chances are your pan's going to be made out of metal. A nonmetal is a very poor conductor of heat and electric current, and so we don't use those for that kind of thing. And those are located to the right of the stair-step line. And the last type is a metalloid. These have properties that are similar to nonmetals and metals, and so they can act like a metal or a nonmetal, depending on the conditions. So the metalloids that we need to know are boron, silicon, germanium, arsenic, antimony, beryllium, and polonium. To classify our elements, we have what are called groups, or sometimes they're called families. And these are the vertical columns on the periodic table. So the group is numbered. So group 1A, the column 1A, is called the alkali metals. Column 2A are the alkaline earth metals. 7A are halogens, and 8A are noble gases. There are more names for other groups on the periodic table, but we don't have to know those. The representative elements are elements that are in groups 1A through 7A. So the columns that are labeled 1A through 7A. And they're called these because they have a wide variety of chemical and physical properties. Most are solids, except for a few gases in one liquid, which is bromine, at room temperature. They go all over the gamut of how they react with things, what they're used for, all of that stuff. The atoms of representative particles, when we look at its electron configuration, the S and the P sublevels of the highest energy level that's occupied are not filled. And if we look at the ends of the periodic table, we could have like 4p5 or 4p1 or 3s2, 3p3. But the highest energy level, so the largest N, is not completely filled with 2 electrons in the S and 6 electrons in the P. The rest of the elements are known as group B elements. We can call them transition metals, and these are what we call the metals located in the D block of the periodic table. And inner transition metals are the elements that appear below the main body, also known as the F block. So transition metals are the D block, and the F block are inner transition metals. Alright, so we're going to stop here and go ahead and look at a periodic table and label one and hopefully color one to help us see this organization on the periodic table.